Hi all, this is Xiong-Fei again to talk about Mathlab, and this time we're going to focus more specifically on the functions of Mathlab in three-dimensional graphing. Now, we've seen in the previous video that this graph can produce basic graphs in Cartesian coordinates. However, we haven't really taken a look at different coordinate systems. For example, let's come here and clear all, and let's take a look at some of the other different coordinate systems. For example, cylindrical coordinates. We can type in a function, for example, cosine of r, and we'll graph that function, and we can also zoom out to see what this graph looks like, and we can see that this graph basically is a ripple in water, or some sort of disturbance in a fluid. Or we can go into different coordinate systems. Let's clear all again. Let's go into cylindrical coordinates. We can see, we can produce a graph here. For example, r is equal to z. We can produce a basic double cone here. Or we can go into different coordinate systems. Let's clear all again. Let's go to spherical. Some of our graphs can get really interesting in spherical coordinates. I mean, you have the basic spheres, for example. Let's return to home view again, just a basic sphere. However, we also have our more interesting graphs. For example, 4 times cosine of phi. That'll actually produce a sphere sitting right on top of the origin. Or we can change this to theta, and this produces a rather interesting looking pouch shape. So really, the power of Mathlab just extends to whatever your mind can think of and whatever you can imagine to mathematically do. Now, let's clear all again, and let's take a look at what Mathlab can do in parametric curves. For example, let's graph a basic helix here. Let's say cosine of t, sine of t, let's just say t over 3 here, and let's just say our bounds are, our minimum t is just going to go from negative, say 10 to positive 10, and this will graph a basic standard helix. We can rotate it and see it from different perspectives as well. So really, the powers of Mathlab in 3 dimensions is just endless, and I hope that you guys get to play around with this and explore a little more yourselves. Thank you.